Okay, so I've got a fairly typical set of Christmas tree lights here, LED operated, long power cable, the usual control box, and then a adapter. This is a, so look here, this is a 120 to 24 volt, 120 volt AC to 24 volt DC converter. And we usually put the Christmas tree in the middle of the room, so we have this unsightly cable running from the Christmas tree to an outlet, and I'd like to get rid of that. So the idea is we take this away and we use a USB power bank. This is a fairly cheap one from Amazon. It's quoted at 36,800 milliamp hours. It's nowhere near that. But this is just the starting point, and we take one of these DC to DC converters, also from Amazon. They're based on the XC6019 IC, this IC here. It takes, for example, 5 volts in and can output up to, I think, 35 volts. It's adjustable here with this potentiometer. So the idea would be to take these elements here, and this is a little prototype that I've created, which allows you to plug the Christmas tree lights in on this end, as usual, like so. And then we take a power bank and plug it in, and we should have some light activity here, cycle through the different modes, like so. Okay, so let's build a prototype. Right, it's been a while, but I'm finally getting back to finishing my lithium-ion Christmas lights, lithium-ion powered Christmas lights project. I want to package it up, so I've bought some project boxes on Amazon, some standoffs, PCB standoffs, which is this box here, some strain reliefs, which is this box here. And let's start with the strain relief. So just looking at the inner diameter here of the strain relief, we're looking at about, I'll make sure that's zeroed, 6.7. So let's drill holes out to maybe 6.5. Of course, we need to find the center of the box first, so I'm just going to do the time-honored diagonal method here. So basically, corner to corner, let's get the center. So, and so. Okay, that's good. Corner to corner. Okay, roughly all right. I'm just going to, I'm not going to center punch this with my metal center punch. Might crack the box. Just going to mark the center here with a drill bit. Like so. Then I think I'm going to drill these out to 6.5. Let's see what I have here. This is a 6.3. I'm going to drill it out. I've realized I left my drill, my other workshop, so one moment. All right, I'm back with my drill. Okay, I'm going to use my, I don't know if this is going to come on camera. Let's see what I can do here. This might be awkward. Drill this on camera? I don't think so. I'm just going to drill this off camera for convenience. see if I can get this out. Fortunately, I can. Sorry. Need a better setup. Okay. So, got two holes drilled here. Let's put the strain reliefs in and see. Well, let's see if they fit. That's the thing. Maybe with persuasion. Might have to drill them out a little bit more, but let's try. This method. I'll go in. Goes tighter is better. All right. Sorry, off camera again. Yeah, I think that's too tight. It's actually compressing the strain relief too much. So we're going to have to go up a size. Do I have another drill? Okay, one moment. Okay, I'm back. I'm going to try a slightly larger drill here. Let's see how that goes. Again, we're doing this off camera. Let's try it. Okay. Let's try that. That's better. More persuaded in a little. Awkward, huh? Okay, that's it there. Okay, I think that works. Question is, will my next piece of the equation fit in there? Probably not. I'll have to address that later. So we'll see. For the USB side of the equation, I'm going to repurpose this old USB lightning cable that inevitably these things stop working. So I'm just going to basically repurpose that for this project. It was a reasonable amount of length, maybe about that, like so. And then I'm going to basically strip this off and see. I might use my blade here to do a better job. So you can see what this looks like inside. so that's how it works. All right, fine. Pull that back a little bit. And we damaged those, so we're going to cut those. Did we? No, we didn't. They're still intact. Okay, good. I presume red and black are the colours in question. Let's try the string. Let's remove the string and put the string relief on. See what that looks like. So I'll be going in like this. Like so. That's a fit. Could be a bit awkward with this braided stuff and this outer braiding. Okay, comes off easy enough. Let's try it. Can we get it to go over? Yes, we can. Good. Okay. Problem is, it's not particularly tight on the string relief, which is not the objective, although if I put it in the box, that may change. Let's do that as an experiment. Let's get it in. So, let's get this in and see, does it do what it's supposed to do. Difficult to get in. I think it's good. Let's get in there. Awkward. Alright, I think that works as a nice string relief, so I'm happy with that side of things. Okay. Good. On the other side, I think that might be problematic. These I also purchased on Amazon. That's the male, we're looking for the female. These are going to be a much tighter fit, I would say. So let's leave that one now. With the board, let's get the board in. Once the board is mounted, the question is, can we get this cable attached easily? It's going to be a bit of a faff, I'd say, so the cable's going to be there. Pull that to about there. Probably easier if feeling it's better if we basically solder or add a couple of small tails there that we solder to. Otherwise it's going to be a bit of a nightmare assembling this. I think it could work. Yeah, if we if we insert it after we've mounted the board. Let's try that. So let's get the standoffs. These are self-adhesive jobbies. Second. So take 4 of these. Like so. Now we mount the board onto them, like so. I'm going to put it on the board first and then put the board in. So this is the power flow. So this means this is the USB side here, which is this side. And let's get them the whole way. Yes, now they're in. Oh, that one. Yes. Now they're all in. Let's get them aligned, squared up as best we can. And then remove the backing. Oh, tricky. There we go. 1. 2. 3. 4. Well, let's get them aligned again. Like so. Make sure we've got the Christmas tree light on this side, USB on this side. Let's get it in there. Okay, there we go. I'm slightly got this lodged. Can I straighten it up, I wonder? Maybe not. No, I can. Good. This one as well. This one. All right, get this pressed down. Right, so far so good. Getting the cables in is going to be a bit of a challenge, but I'll address this now. For the Christmas tree side light, I purchased these on Amazon. They're not an exact fit, so we're going to have to modify those. So just let me stop here quickly, and we'll get back to that. Right. So on the Christmas tree side of things, we have this connector. It's a 2-pin D connector. So I tried to find something equivalent on Amazon. I found these. Unfortunately, they're pretty close, but the D isn't deep enough. So we're going to have to modify these to suit. So put another way, this simply won't fit. It's close, but it's quite, you can see the difference here. Now, I prefer to have got the right connector, but it's just simply not available. So what I'm going to do is I'm going to modify this. Put that out of the way there. I think I should be able to do this on camera. We're going to do a little bit of surgery on this connector. As follows. So first thing I'm going to do is I'm going to open up this part here. I'll probably just do that with the, you know what, I'm going to do it in one go. Makes much more sense. I'll show you what I mean. Just basically go deep, carefully. Now, basically cut the as best I can, but not vertically bend. See? Yeah. about where the threads stop. And then I'm going to come in. See. This is a bit awkward again. I need to turn this around, like so. And come in to where that cut was, roughly speaking. Okay. I think that's that is. There we go. All right. So we removed a chunk of it. That's amazing what that connector looks like there. But we haven't removed too much material, hopefully. We should be able to get that to fit, which it does pretty nicely. Now the question is, do we still have enough threading? This is supposed to be an IP rated, I can't remember which one, but waterproof connection. I'm not going to be using these indoors, but let's see if there's enough of the thread remaining that we can get this. Yeah, it seems to be. Yeah, so I think that's a workable solution. So we've got that done. Okay, so we've modified the connectors. Okay, now back to the strain relief issue. And these strain reliefs are going to be a little tighter than expected. So let's see if we can persuade these to go in. One's actually a damaged one. Take another one. One moment, please. Okay, new idea. A little bit of WD-40 in it, and on the cable itself. See if that works. Oh, it seems to be a lot better. That could be working. Come on. You know what? I think that's probably good enough. The cable sheath, the sheath is up to there, and I think this is going to operate pretty well as a strain relief. The question is, will we get it into the box? That's an interesting question. We'll see. Clean up this 40. Quite messy. Right. Let's take this one out. Like so. Let's see if this will fit. With the cable in it. That's the question. I really have the strong feeling I should be out by the strain reliefs, you know, but I'm going to persevere on maybe just widen out that hole a little. It's another option. Do that off camera. That's a lot closer now. Maybe a tiny bit of persuasion. And there we go. All right. Oops, almost. Okay. That looks like a reasonable job. It's not perfect. For my purposes, for initial prototype, I think it's good enough. To be persuaded. No. All right. Now the wiring, which is kind of tricky because we've already got the board in there. So let's start with the Christmas tree light side. Open up those connectors. See if we can get these in, persuade these in, and at this level. So, nice drive for as small as possible is probably causing us have some problems here. But it's going to be okay. Test those two for continuity while we're at it. So this one. Okay. And this one. Okay, that's good. Check connections one more time. All right, now the other side, which is the USB side. I want to clean this up a little bit. So can I cut up some of this fluff? I don't like that. Stuff. Burn that off a little bit, I think. So the assumption here is that red and black are positive and negative, but I don't know that for sure. So I think we're probably going to have to check that. Let's get them straight in there first. So, can I get a USB, something USB around here? One moment please, I got a power pack. Okay, so I'm back with the Christmas lights adapter and an outlet that I can get this plugged into. It's polarized. Let's just confirm that the markings here are correct. So with the D in the this orientation, we have positive at the top and negative, sorry, positive at the bottom and negative at the top. We're on DC volts here. Let's have a look. Let's just confirm that. Yeah, we're getting 22 volts or 24 volts roughly. So that means the markings are correct. So we're going to, slightly annoying, but the Amazon connectors to the boards here have a different orientation. And that's absolutely fine. We're just going to have to swap the wires here. So let's get it disconnected from the power block. And let's get these loosened. All the way. And let's get this rotated. So, alright, process. Oh, sorry, that one in. This one. There we go. Okay, let's try it again. Power block here. And with the D in this orientation again, plus should be down here. Here into play. Yeah. Okay, of course we're at 6 volts here. So we're going to adjust this. I'm going to adjust it probably a little lower. Compromise between battery life and brightness, obviously. Here's the Christmas lights. Right there. Let's get them connected. See if they work. Which they're not at the moment, but remember we're at 6 volts. So let's get this adjusted. There's a little potentiometer here on the board. So let's see if we can get these to light up. Is that small enough? Can I screw it around? Yes. Okay. Not clear. Now we're getting any output there. Let's monitor this. Let's set it to 22 or 24. And see where we get to. Okay, so my clips here. I definitely need better clips. Oops, sorry. And the camera. I definitely need a better camera setup as well, but so be it. Okay. Let me go and get different probes. And back with a different set of probes. More on the probe side than the clip side. So we'll look here again. Orientation. that's much better. Okay, here we got 6 volts. Sorry, 6 volts. Let's get this up to, figure out which way this turns. Oops, that's contact. Probe. Okay. Now, look here. Okay, that's going up. All right. Get this up to the. Let's get it up to the 20 mark. Let's say 20 volt mark. Roughly. Okay, now let's see if we can get these lights to light. And are we getting any light? Yeah, are we? No. Yes, we are. Okay. It's quite faint. Why that is? What if I were to switch off the lights here? Okay, we've got some light action. It's pretty faint. I think we'd probably like to get that a bit higher. Let's just adjust this by side. Okay, there we go. All right. Okay, it's working. So next thing we need to think about is let's actually see what that voltage ends up being. So we're at the about the 21 volt range there. Interesting. Thought that's what I'd actually set it to originally. Okay. Last thing I think here is if we want to do an adjustment, we'd have to open the case up. Question is, should we drill a hole in this lid for access? I think not, actually. I think it's a clip-on. I'll show you what the case looks like closed. It's a clip-on the case. I think we'll leave it like that. Okay, so that finishes the project. I would like to investigate a little about what happens when we have a failure, like a short circuit at this end. I know power packs typically have short circuit protection. So let's validate that, because that's a safety safety consideration. Can I open this case up? Should just clip out. Oh, let's put the light back on. Okay, sorry for any blinding there. Okay, so there's the lid off. Let's keep that power brick. Let's see here, we've got a few lights. I'm going to deliberately introduce a short here and see what happens. I think I already tested this power brick. It has short circuit protection. Let's just verify that. Let's see what happens. Nothing, actually, which is interesting and surprising. I thought like the power brick would go into some sort of current limit mode. Doesn't seem to be. So what happens if we short circuit this end? Also nothing. Oh. I think if we short circuit that end, we actually have a little click there. Interesting. I think we should investigate what type of circuit this is, what type of IC they're using, and see if it has built-in short circuit protection. But let's just check whether voltage output is still around the 21 mark. It is interesting. Okay, so what I would suggest we do is we investigate the circuit a little bit more, which I'm going to do now offline and come back. But I'm interested how this circuit performs if there's a fault, for example, the short on the Christmas tree lights. That's important. And of course on the USB side and the power brick side. So I will come back. Okay, so I did a bit of research. This DC to DC converter is based on the XL Semi XL6019, and it has built in, so this IC here has built in thermal protection and built in current limit to 5 amps. So there's no way that this USB power brick is going to deliver 5 amps or 5 volts. To test the current limit, what I decided to do is I don't have any high wattage, low ohm resistors as loads. So I'm going to take this, I think it's a 40 watt halogen, 43 watt halogen bulb. It's got a cold filament resistance of around, if I recall, around 28 ohms. I'm going to double check that now. Let's have a look. It's got enough continuity. .25 ohms cold resistance. So I think that's a decent load, rather than the aggressive short circuit I was doing earlier. I'm going to basically take the other end of this here to get access to, when I ordered these, I also got the male end. That will allow me to hook up to the bulb as a load. So let's do that. So red is going to go to bulb here. See if we can keep all of this on camera. Okay. Black. Is going to go to the other end of the bulb. Let's make sure we don't short circuit these. So, other end of the bulb. Okay, so now we've got a 25 ohm resistive load on this, capable of dissipating 40 watts because it's a 40 watt light bulb. We're not going to get anywhere near that. And then we're going to have a look and see what happens to the voltage when we apply power. So, look here. Actually, let's run without the load for a second. Make sure everything's okay. Alright, so here we go. Switch on the power brick. Okay, and we're getting our 5 volts out. And then what I'm going to do is I'm going to, let's get down, put on the load. You see we drop down. The power brick, we're already dropping down. And you can, interesting, yeah. There we go, it's attached there. If we look at the power brick, so we've dropped down on the output of the power brick. We're in current limit mode and the power brick's actually turned off. Let's do it again. You can see there that the power brick goes into current limit mode. Okay, so that's good. So we've established that the power brick will go into limit on an overload, and I think that's what's happening there. The regulator itself isn't going into overload mode, but we know that we have current limit. We saw that earlier on a full short, so I think this is reasonably safe circuit in the presence of a fault. Okay, so next thing is I'm going to fix a couple of things on the board with the strain relief, as I mentioned earlier, and probably I am going to drill a little hole for the adjustment, because that will also allow me to see if the converter is operational. The LED will come on and we'll be able to see it through that little hole. So I'm going to do that. Okay, so a few minor improvements. I noticed that there's a little bit of insulation damage there on the USB side positive lead. I don't like that, so I'm going to fix it. So let's open this up. Take that lead out. And what I'm going to do is just put a tiny little bit of heat shrink over that rather than mess around with the rest of it. Just to protect it. What we have, I think something around this size here should do. And might cut it down to size a little. Let's get that on. Yeah, bring it down to there. Okay, just heat shrink it in situ. All right. Strain relief issue, so let's get that in. So that was relatively quick to do. This back in. Terminal block. Go again. I definitely think I did this differently next time around. But again, that's the thing with prototypes. You learn from them. Oh my god, this is awkward. Probably this is going to break off. Unlucky, hopefully not. There we go. No, not happy with that at all. Try it again. Oh, look at that. As I suspected. Oh, it's still intact. Good. A little worse for wear, I'm sure. This is awkward. Again. There we go. Okay. Put that in. Now, on the matter of strain relief, I'm not quite happy with this one. What I'm going to do is, my idea is to just put a bit of heat in that work. A little cable tie around that on the inside. try it. Basically, somehow bring this up and around. Up and around, like so. And basically get it down there on the cable. I think that will operate as a decent strain relief. I'll get it clipped off. Definitely need a new pair of snips. These Harbor Freight ones are disintegrating. Let's see if we can get this snapped off. Don't even cut properly. Just terrible. They're not that old, do they? Probably less than a year. Okay. Absolute junk. Alright. So that's that. The strain relief. Now the last thing is the little let's call it a access hole for the potentiometer and secondary function of allowing us to see the LED is lit. So we're going to mark this up here. Let's have a look how to do this. So one way to do it is to basically mark the take this like this maybe. Basically by eye, that's the so look here. Yeah, it's roughly okay. I need a new table as well. I've realized that this is very noisy, so I won't be using this. I'll be covering at least for subsequent videos. You live and learn. Okay, and then at this position here, basically it's here. Bring this over, like so. That should be the center point. There. Okay. Measure twice, cut once, and all that. All right. I'm going to go with a smaller hole this time. Let's have a look. Doesn't really matter, but let's see what it is. It's about 3.8 millimeters. And it should be fine to cover that. I don't want the hole too big. We don't want unintentional access. Right. I may be able to drill this one on camera. Just get set up here. I do need a little underlay. Which I do this on camera. Oh, okay. I'm just going to grab a small underlay. I'm back with my underlay. Let's get this drilled. Oops. Sorry for the camera knocking again. I should have drilled that the other way around actually, because we have basically the exit of the drill breaking through, but we can clean that up. pretty easily. Like so. Yeah. All right. Okay. Let's have a look and see, did we get that drilled in the correct position? And I would say that we didn't. How did we manage that? Interesting. Yeah, we made a mistake there. And that happens. Okay, luckily we have more boxes. Not gonna be there. I'm not going to edit that out. This is a warts and all video. So, let us learn from a mistake. And let's do it again. Okay, so I think the reason that happened was I did it upside down. That was the issue. Okay. So we'll also drill it from the right side this time. So we can get the positioning here is correct. Let's get that lined up. Okay, and then the positioning here should be there. Yes. All right. There you have it. Okay. So I think that will be much better. And we'll drill from the other side now. I've got my underlay. Let's get the okay. There we go. That up. The exit point now is on the other side. Which I'm going to clean off anyway, if I can. Okay. Right, get rid of that. Now did we get it right? And yes, that looks much better now. Okay, so now we have an access hole for pot adjustment. Good. We can clean off the markings. Okay. And the question is, is the lead visible when we switch this on? Does it shine through? I know it's not directly above it, but and the answer is no. Let's switch off the light. Oh, power brick isn't on. That would help. Oh yes, good. So lights back on. Looks like you can still see the lead. Turn that off. No. How do I turn this power brick off? No, you can do it this way. Now, let's see if we can get that on. Yes, you can see it's losable there. That's good. Okay, mission accomplished. That concludes it. So I hope that was interesting for you all. Actually, it doesn't conclude it. We need to do one final test with the Christmas lights. Make sure everything's operational in here. And actually a voltage test because I'm messing around with stuff. So I'm gonna do that. And positive at the bottom, negative at the top. And we're getting 21 volts, give or take. And let's check the Christmas lights. So that's very nice. Switch off lighting. Yes. Okay. So that's the finished product. I'm quite happy with that. I may do a follow-up video on the performance of this, i.e. what the battery lifetime is, but from previous testing, I think it was around a day, which isn't perfect, but it's also better than having your Christmas tree light power leads trailing across the room if you've got the tree in the center. So anyway, that's the prototype. If folks are interested in seeing what the performance of this is, I'll do another video on that. Thanks for watching.